Hello everyone, here our question is van der Waals constants of for gases A, B, C are given as follows. So here value of van der Waals constant, that is A and B, for gases A, B, C are given, and based on that three question has been asked. First question has highest critical temperature, second is the largest molecular volume, and third is most ideal behavior around STP is. So see, for solving first question, critical temperature is equals to 8A upon 27 RB, right? This is the value of your critical temperature, where R is your universal gas constant. So higher the value of higher the value of A by B ratio, higher will be the critical temperature. Higher will be the critical temperature. Okay. So see, if you draw one more table here of ratio of A by B, it will be 1.501 into 10 raised to the power 4 for gas A, 4.053 into 10 raised to the power 4 for gas B, and 1.89 into 10 raised to the power 4 for gas C. So here you can clearly see that the highest value of A by B ratio is for gas B. So the highest critical temperature will be of gas B. So for answers, I will write here highest critical temperature will be of gas B, because it has highest A by B ratio. Now second is the largest molecular volume. Okay, so see, molecular volume is directly proportional to critical volume, and critical volume is equals to 3B. So from here, critical volume is directly proportional to the B value. So from this relation, you can also say that molecular volume is also directly proportional to the B value. And here, higher the B value, higher will be the molecular value. Okay, so the highest B value is of C, gas C, right? So your largest molecular volume is of gas C. So your gas C has highest molecular volume because it has highest critical volume, because it has highest B value. Now see, third question is the most ideal behavior at STP. So here the concept will be used. Uh, if critical temperature, if critical temperature is close to 273 Kelvin, then then gas will behave ideally around STP. Okay, so we need to calculate the critical temperature for ABC gases, right? So if I make one more column for critical temperature, and the value will be formula will be used is this. So after calculation, you will get the value of critical temperature for A is 534.97 Kelvin. For B is 1444.42 Kelvin, and for C is 677.07 Kelvin. So the value most close to 273 is this, okay, 534. So here gas A will behave as ideal gas at STP. Okay, so this is the solution for this question. Okay, thank you.
Hello guys, in this question it is saying that consider the van der Waals constant A and B for the following gases. These are the two gases, these are the gases given here: argon, neon, krypton and xenon, and A and B are given. So argon A is 1.3, for neon A is 0.2, for krypton A is 5.1, for xenon A is 4.1. And for argon B has the value 3.2, neon has the B value 1.7, 1.0, 5.0, and it is asking from us that which gas is expected to have higher critical temperature. We have to find out from these four gases which gas will have higher critical temperature. We have these options here. So first of all, we will find out what is the meaning of critical temperature here. So there is simply a formula which is TC, critical temperature, is equals to 8A divided by 27 multiplied by RB. Now in this question we have to find out which gas has the highest critical temperature. So if the value of AB for any gas, if the value of AB higher, if the value of AB higher, then this is directly proportional to the critical temperature, right? So if AB for the gas AB value higher, then the critical temperature will also increases. So we will solve out all the AB value, A by B value for all the gases here. So first of all, we will find out for the argon. Argon here, this is 1.3 divided by 3.2. This is 1.3 divided by 3.2. So after solving this, we will get here 0.406, right? Now we will calculate for the neon here. Neon has the value A by B will be equals to neon 0.2 divided by 0.2 divided by 1.7. So the value of 0.2 divided by 1.7 will be 0.118, right? Now we will talk about the krypton. Kr has the values A by B value will be equals to, krypton is this 5.1 divided by 1, this will be 5.1 divided by 1.0, this will be equals to 550, this will be equals to 5.1, right? Now if we talk about the xenon, this is xenon here. Xenon has the value 4.1 divided by 5, 4.1 divided by 5.0, its value will be equals to 0.82. So now as we can see here, the krypton has the maximum value of A by B, which means it has the maximum critical temperature. So what we have to find out is expected higher critical temperature. So krypton will be our answer. This gas krypton will be having higher critical temperature according to the A or B value. So this is the answer. Thank you for watching. Best of luck. Bye bye.
Hello everyone, let's start the question. Question says that the combination of loads which does not represent isothermal expansion of an ideal gas is. Okay, so in case of ideal gas, if you write the equation is PV equal to nRT. Okay, and here we are talking about isothermal expansion. Isothermal expansion. Okay, that means the temperature is constant. So if we see in the equation, n is constant, r is constant, and t is also constant. So whole term is now constant. Okay, so we can write PV equal to K, okay, where K is constant. I have written K for whole term. Okay, so if we talk about the first graph, we can say that we can write in this way also, P equal to K by B. And if you imagine the equation of straight line, that is y equal to mx plus c. Here m represents the slope. Okay, slope. Here let's say slope is m, which is in the equation is k. Okay, and 1 by v is x, that is in the graph it is given as m, so vm, and p is y. So we can say from this equation we can say that this graph is correct. Now coming to the second graph, the graph is between p and vm. Okay, so if we write for this, so now we have p, v, that is constant, and if we draw the graph between p and v, then graph will be like this. It will be like parabola. Okay, it will be like this, P and VM. But here we can see that this is a straight line going down, so this is the wrong graph. Okay, now coming to the third graph, it is PV on the y-axis, PVM, and P on the x-axis. So in the third graph we can see that we can see here that the PV is already a constant, and here the graph is P. So if we changing the value of P, it will be a straight line because the whole term is constant. Okay, now as the whole term is constant, this will not change even the P is changing. Okay, the whole term will be constant always, so this graph is correct. If you see the last graph, it is between change in internal energy and VM. So if we take this case, so the case is isothermal. That means del T will be 0, no change in temperature. If we write for formula del U, then it will be NCV del T, and we know that this is 0, so this term will also be 0. Okay, so if we see the graph, okay, so graph should be like this. It should be constant. The change in internal energy will not be changed, it will be constant. So graph should be like this. Okay, so this is wrong graph. So our correct pair are A and C, and wrong pair are B and D. Okay, so if we see the option B and D, this is the correct answer because they do not represent the correct plot. Okay, so we can write the correct answer is correct answer is B and D. Thank you.